So another property of the D block elements. So there is formation of complexes. So this is another striking feature for the D block elements. So first of all, what is the complex? So how can it form? So when you observe the complex, a complex is formed when a central atom, see this, the central metal ion, it is surrounded by the molecules or ions which form the attaching covalent bonds with the central metal atom or ion. So that is known as the complex. So what is that? The metal ion series. The M is indicates the metal ion, and the X means it is a ion or a ligand. So this is the typical structure for a complex. The complex indicated with the bracket series. So within the bracket, the metal ion present and as well as the ligands. So here indicated with the X. So the X or ions or molecules are surrounded around the metal ions. So this is known as the complex. So here, what is meant by another one? The word that is a ligand. Here, ligand means so this is a molecule or ions. So the molecules or ions that donates the lone pair of electrons to the metal ion to form the attaching covalent bonds. So that molecules or ions known as the ligands. So ligand means it must be donate the electrons to the metal ion to form a covalent bonds. So that is known as the ligand. Now here, why the D block pigments? So most of the D block pigments are an ability to form a complexes. Then why they form the complexes? This special properties for the D block elements. So this is due to the presence of small ionic size of the D block elements and high charge. And also the one of the most important ones, so that is relatively available of G orbitals, so partial filled D orbitals or empty G orbital. So due to presence of that G orbital, the most of the D block elements are involving in the formation of the complexes. So why? What is the reason? So due to the small ionic size and a high charge and relatively available of the G orbitals. So due to these factors, the D block elements can form the complexes. The D block elements can form the complexes electrically neutral form. So like this, see this one, for example, electrically neutral means the complex having the no charge, and they can able to form the positively charged. That means the complex having the positive state, that is positive charge oxidation state. And here also negative charge complexes can be formed by the G block elements. The negative charge means the complex has a negative charge on the complex. So these are the some complexes that can be formed from the G block elements. So remember these factors. So these are the elements due to the small ion charge and high charge and relatively available of partially filled D orbitals and empty D orbitals. So due to these factors, it can form the complexes. So remember this. They can able to form the neutral complexes, positive and negative complexes. See this one. So here is some ligands. See this one. Carbon monoxide, nitric oxide, ammonia, water, chloride, cyanide, etc. So these are the some examples for the ligands. So by using these ligands, we block elements now involving in the formation of complexes. See this. So with this ligands, the D block, most of the D block elements can form the complexes. So here are some examples for the complexes. So here it is the cobalt involved in the complex formation with the ammonia. So here it is the copper, it is the yttrium and iron. This is also iron and nickel, etc. So remember that one. So most of the d orbitals ability to form complexes. So the next property of the d block element. So there is magnetism. So yes, we know the what is meant by magnetism. So here, so based on the magnetic field is applied to the substance. So based on that, mainly there are two type of magnetic behavior we can observe. So that is diamagnetism and paramagnetism. So these are the most knownly magnetism of the any species. So here, what does it mean by how can you define the diamagnetism? Magnetism means, see this one, the substance are repelled by the applied field, applied magnetic field. So this is when the substance are repelled by the applied field, then that magnetic property is known as diamagnetism. And then what is mean by paramagnetism? When the substance are attracted by the applied field, so that magnetic property is known as paramagnetism or paramagnetism. And there are some more magnetism properties that we are seeing. So that is ferromagnetism. Then what is mean by ferromagnetism or ferromagnetic? So it is also mostly it is known as the high paramagnetism, high paramagnetism property. See this one. How can you define the ferromagnetic? The substance which are attracted very strongly. The substance which are attracted very strongly. So that is known as the ferromagnetic. As we know that the ferromagnetism is an extreme form of the paramagnetism. Then let's see the why the D block elements can show the magnetism property. Here it is. Most of the transition elements and the compounds can show the paramagnetism. So this is due to the presence of unpaired electrons in their compounds or in the elements. So when we call it is a paramagnetism. So here it is when the compound element having the unpaired electrons, then automatically they will show the paramagnetic property. So remember that one. So lone pair, unpaired electrons. The compound or element having the unpaired electron, then automatically it will show the paramagnetism. And each that such unpaired electron having its own magnetic moment. Now here it is the magnetic moment of any transition elements or compounds or ion. It is given by the. So this one you can easily calculate the magnetic moment for the any transition elements or any element by using this simple formula. So here it is the magnetic momentum. It is indicated with the mu s. Mu s is equal to under root n into n plus 2 Bm boromagnetic. So by using a simple formula, you can easily calculate the magnetic moment of any element or any compound. So here, what is the formula? Mu means it is the magnetic momentum indicated with the mu is equal to under root n into n plus 2. So here n means the number of unpaired electrons present in the element or compound are high. So remember this simple formula, then automatically you can easily calculate the magnetic moment of any compound or ion or element. Here N means unpaired electrons. So if you observe these table, so there are some G block elements. There are some 3D series elements are present in the there are a stable ionic state, and it's the magnetic momentum value. See this one. So these are the these elements with the stable oxidation state in the ionic form, and at this stage that particular molecule containing these type of outer configurations, and this was the number of unpaired electron present in this oxidation states of individual elements. And this is the paramagnetism, that means magnetic momentum for the particular element. If you observe the scandium in the +3 oxidation state, that scandium has the d0 elements. In the d orbital, there are no electrons present in the +3 stage for scandium. So that is why, what is the N? N means unpaired electron present in a particular ion or element or compound. So here there are no elements are present. So that means N is equal to N becomes 0. Then substitute the N value in the magnetic momentum formula. What is the magnetic moment formula? Mu S E is equal to under root N into N plus 2. Then coming to the titanium. If you see the titanium in the +3 stage, what is the outermost configuration for the titanium +3? So in the titanium +3 stage, 3D1 it is the outermost configuration. 3D1 means in the d orbital only one electron is present. That means N is equal to what? N is equal to 1. If you substitute the N is equal to 1 in this formula, you can easily get the magnetic momentum. If you substitute the N value in this formula, 1 into 1 plus 2. What is that? 1 plus 2 means 3 under root 3. So under root 3, value of under root 3 is nearly is equal to 1.7. So like that you can easily calculate the remaining elements in their particular oxidation states. So one thing you have to remember, you have to know the how many unpaired electrons are present in a ion element or compound. So based on that you can easily find. See this one? If you observe this one, nickel plus 2. In the nickel plus 2, the outermost configuration, so that is 3D8. 8 electron present in the d orbital. Then how many number of unpaired electron present in 3-8 configurations? So for this purpose, you have to fill up the electrons as per the rule. 3-8 means 1, 2, 3, 4, 5, 6, 7, 8. 6. These are the paired electrons and these are the unpaired electrons. So in the 3D8 state, 2 unpaired electrons present. So that is why N is equal to 2. And substitute the N value in this formula, then you can easily find out the magnetic momentum of the nickel plus 2 bond. So this way you have to find out the magnetic moment for the any compound ion of substance. So this is a structure of the molecules or electrons. See this one? So this is the when the magnetic field opens, the molecules or electrons are arranged in this manner. If you apply the magnetic field or in the presence of magnetic field, these arrangements have become the particular arrangements. And this is the arrangement for the ferromagnetism. The another property for the D block element, so that is catalytic activity. So here the catalyte or the important for the industrial bulk production of many chemicals. And why we are using the catalyte catalyst in any reactions? So because we need more quantity of a compound, then we need to use the catalyst. A particular catalyst will be used in a particular reaction. Then only we can gain the more quantity of the products. So remember this. So that is why we are using the catalyst in a particular reactions. So here, many deep block elements will act as a catalyst. So in their ionic form, they can use in many chemical and biological reactions. Then why the G block elements will act as a catalyst? So because of some characters that D block elements have. Now here is some factors. Due to these factors, the D block elements will act as a catalyst. See this. Due to presence of a vacant drb due to they will show the a variable oxidation states. That means more than one oxidation states. Another one, so that is the tendency to form in reactions intermediate with the reactant. That means they can form, they can ability to form the intermediate with the reactants. And another one, so that is the presence of defects in their crystallitis. And next one, so that is provide a large surface area with the free valences. So due to these properties that will have the D block elements, then the most of the D block elements will act as a catalyst. So what are they? Due to presence of vacant GR codes, that is partially or available of empty GR codes, and they will show the variable oxidation states, more than one oxidation states, and they can form the intermediate compound with their reactants. And defects, with the presence of the defects in their crystallitis and for the loss surface area, the free valences. So due to this one, these factors, most of the deep block elements will act as a catalyst. So here it is mentioned some of the important catalysts which are used in a specific process and specific reactions. See this one. In the hydrogenation reaction, we can use the nickel as a catalyst. Here the catalyst is mainly used for hydrogenation of oil in order to manufacture vegetable. And also in the Haber process, we can use iron as a catalyst. Haber process means the synthesis of ammonia. In the synthesis of ammonia, you can use the iron as a catalyst. So in the manufacture of the sulfuric acid, so the process is known as contact process. So here is what is the catalyst? So vanadium peroxide is used as a catalyst in the manufacture of sulfuric acid. And titanium tetrachloride, see, so the titanium tetrachloride is used in the manufacture of a high density polyethylene, that is polymerization of ethylene. So in that process, titanium tetrachloride is used as a catalyst, and in the hydrogen, the decomposition of hydrogen peroxide process, the manganese dioxide is used as a catalyst. So these are some examples of the catalytic behavior of deep block elements. So remember that one, most of the deep block elements will ability to act as a catalyst.